Okay, today we're going to talk a little bit about line drawing and functional groups. Line drawing is kind of the hieroglyphics that chemists use to communicate with one another. There are some rules for line drawing. First of all, every end or bend in a line is a carbon. We don't draw out the hydrogens, okay, except for when they're attached to a heteroatom, and I'll tell you what heteroatoms are in just a minute. The number of hydrogen atoms on a carbon is implicit. In other words, we need to know a little bit about carbon. If carbon has a formal charge of 0 on it, it's going to make 4 bonds. If there's a positive or a negative charge on that carbon, it's going to make fewer bonds. Okay? And finally, heteroatoms. Heteroatoms are things that are other than carbon or hydrogen. Okay, and we always draw those out, like oxygen, sulfur, nitrogen, chlorine, bromine. You get the idea. So let's try a couple. So what does this look like? Let's first look at this molecule. And in this molecule, we can see that we have 1, 2, 3 carbons. So let's draw out our 3 carbons. 1, 2, 3, end or bend. So it's 3 carbons right there. Notice on that third carbon, it's attached to an oxygen. So let's draw that out, and let's draw the hydrogen. Not a very good hydrogen here. That's attached to it. Let's try another example. So how many carbons are in this one? Count them up. There's 1, 2, 3, 4, 5, 6 carbons. So let's just draw out our zigzaggy line. 1, 2, 3, 4, 5, 6. We got our 6 carbons there. Notice on the first 2 carbons, there's a multiple bond right over here. So we're going to draw that out in our structure. There's also a multiple bond between this last carbon that we drew and an oxygen. So let's draw those 2 bonds. Oxygen is a heteroatom, so we're going to draw that into our molecule. It's attached to, that carbon is attached to a chlorine. Chlorine is also a heteroatom, something other than carbon or hydrogen. So we're going to draw that out. Okay, you're going to need to practice these. The only way you get better at doing something is to practice. Let's talk about functional groups. So functional groups are just how we name arrangements of atoms. Let's look at a couple examples. So this particular arrangement is a carboxylic acid. What I'm looking at is this carbon here, this oxygen, and this oxygen, and this H. So I got the COOH arrangement, and when it shows up like this, we call that a carboxylic acid. Here's another type of functional group where I have a carbon attached to an oxygen that's attached to a hydrogen. That's called an alcohol. So how am I figuring these things out? Well, I've had a lot of practice, and what you can do to start off is in your Canvas page, there is a flow chart that looks something similar to this. Okay, and I'm going to be referring to this flow chart. You can go to your Canvas page and print off a copy or have it up while we're going through this. All right, let's go through a couple of these functional groups. So if I'm using my flow chart, I look at the molecule. Remember, this is all just zigzaggy lines. All that's on here is carbon and hydrogen. If I look at my flow chart, I look all the way to the left, and I see that the molecule only has carbon and hydrogen, and there are no multiple bonds, no double or triple bonds on here. So if that's the case, if I'm looking at my flow chart, I would come up with the name alkane for this. Okay, let's look at this molecule. Again, just zigzaggy lines, no heteroatoms, so just carbon and hydrogen. There's a double bond in here. So if I'm looking at my flow chart, it says that it's got a double bond. We call these sp2 hybridized carbons. So this would then be called an alkene. All right, last one that we have that just has carbon and hydrogen is this molecule here. Notice there's a triple bond. This is what's called an sp hybridized carbon, these 2 carbons here. And when we have a molecule like this, looking at our flow chart, This would be called an alkyne. All right, let's try some more advanced ones. Okay, this molecule, it has a heteroatom. So if I'm looking at my flow chart, I look to the right and it says molecule contains CH and other atoms. So my choices are has a nitrogen, nope. Has a chlorine, bromine, or fluorine, no. Does not have a nitrogen atom. Okay, this one does not have a nitrogen atom. This is an oxygen atom. It's only got one oxygen atom. So if I look down at the choices that has only one oxygen atom, it says has an oxygen atom bonded to an sp3 hybridized carbon. No, we actually saw that on the previous one. That would be an alcohol. Has an oxygen atom bonded to a carbon, to two carbon atoms. No, this one has the oxygen atom doubly bonded to a carbon. Okay, so it does not have an oxygen bonded to an sp3 hybridized atom. So is the C double bonded O, so this carbon, is it bonded to two other carbon atoms? 1, 2, yes. If I look at my flow chart, that's called a ketone. How about this one? Oh, similar on our flow chart, but this carbon atom is not bonded to two other C atoms. It's bonded to just one, and then it's bonded to a hydrogen. If I look at my flow chart, that is considered an aldehyde. Okay, let's go back on our flow chart. This molecule here has two oxygens. And my choices for that are, has my C double bonded O is bonded with an OH group? No, it's bonded with an oxygen that has a carbon. So if I look on that flow chart, that means that this is an ester. How about this one? Ooh, this one has an oxygen and a nitrogen. So if I look at what molecules have a nitrogen, so again, I'm looking at the right side of my flow chart. It says that the carbon atom is doubly bonded to the carbon that is doubly bonded to the oxygen here is also bonded to the nitrogen. If that's the case, this is called an amide. Okay, one more. So if I look at my flow chart, again, this one has two oxygens, but instead of having an O with some sort of carbon on it, it's got an OH. And if I'm looking at my flow chart, that means it's a carboxylic acid. Okay, we have some other types. We have, if it's just singly bonded to an oxygen, it's an alcohol, and there's only one OH. If it's singly bonded to a nitrogen, it is an amine. Wait a second. What if I had other alkyl groups out here? Oh, those could also be amines, as long as it's got that nitrogen where it's only got single bonds to it. I also have, if I had an alkyl halide, so either a bromine, a chlorine, or iodine. In this case, this molecule is called an alkyl bromide. Following that same flow chart, I could have alkyl chlorides or I could have alkyl iodides. All right, well, what you need to do is you need to practice some of these. Use your flow chart. That's the best thing that you can do.